Hey boys and girls, Mrs. Perlin again. How are my scientists doing? We left off with me showing you those two graphs. Remember, we're trying to figure out the playground problem the principals gave us. So we have Carver Elementary and they are experiencing their playground's cold at night and then it's getting warmer throughout the day and the kids are okay. But at Woodland Elementary School, it's cold in the evening, gets warm, but it gets super duper hot in the afternoon and kids are uncomfortable on some days. So first we're checking to see if it's maybe the types of weather that are there. Scientists like to look at one thing at a time to solve a problem. So we're looking at the types of weather. So we have the principals show us the graphs. We looked at the graphs in our last lesson and I asked you to compare them because scientists always compare data to see if maybe they can figure something out. And so looking at the graphs, a lot of you commented on the things I'm about to read to you right now. Okay, so this is what you said. The first question says, what is the weather like on Carver's playground? And so this is what a lot of you said. They had 9 sunny days, 3 cloudy days, 1 windy day, 1 rainy day, and no snowy days. What is the weather like on Woodland's playground? They had 9 sunny days, 3 cloudy days, 1 windy day, 1 rainy day, and no snowy days. So a lot of you said they're exactly the same. The graphs were exactly the same, which is telling you what? That both playgrounds had the exact same type of weather. So when we think about cause and effect, we know what the effect is, right? That Woodland's playground is getting a lot hotter and we're trying to figure out the cause, and we know the cause can't be what type of weather it is because we know that it was the same in both places. So we can just X that off of our list. So now we need to think of another reason for this temperature difference. Okay, so we know that it's not the types of weather that the playgrounds were having. So now we need to think about, why do the playgrounds get warm? Why do they get warm? Well, typically places get warm if the surface is warm. If the surface is cold, then that place is going to be cold. So what is that thing I just said? Surface, that word. Let's look at that word, surface. You see surface? Surface. So the surface of things is the outside of them. Like this is the surface of my chair, and this is the surface of my board, right? When we go outside, we're walking on the Earth's surface. The Earth is the planet that we live on. Earth is the planet that we live on. So that's the Earth's surface. So let's think about this question. Why does the Earth's surface get warm? Why does it get warm? Let's look back at the pictures of the playground. I want you to think about, why is the playground getting warm? So let's check out these playgrounds again. Look, remember the top playground, the 3 pictures are of Carver Elementary's playground. The bottom 3 pictures are of Woodland Elementary's playground. So at nighttime, both playgrounds are cold, but then in the morning, they start to get warm. So what is different at night versus in the morning? What do you see in the sky that's different? Do you see the sun? Maybe it's the sun that is the reason for the playground warming up. Okay, so if we think that the sun is the thing that warms up the Earth's surface, as scientists, we need to investigate that to prove it. Now, especially in Michigan, I can't just go outside and say, okay, I want to have sun shining on this surface and no sun shining on this surface, because right now it's cloudy and there's no sun at all, and it could be snowing in 5 minutes, who knows? So what scientists do is they create models. So scientists compare things, they observe, they communicate, and they create models. And so we're going to create a model today of the sun shining on a surface to try to prove our prediction, okay? So over here I have a little bit of a setup. Let me show you what we have here. We have this black rubber. This is going to be our surface, okay? And we also have, can you see over there, we have a light, because I can't bring the sunshine in here. It can't be shining down in this office. So instead, we're going to have the light, and if I plug it in, it's going to shine just like the sun does. Okay. Now over here, we're going to have another surface. So if you think about, if we have to prove that yes, the sun does light up the Earth's surface, we need to have one surface that's underneath the sun, and then we need to have one surface that's not underneath the sun, right? And what tool are we going to use to measure the temperature? What tool have we been talking about? Hope you're thinking the thermometer. I have my thermometer right here. Actually, I have two thermometers. So we're going to make a little surface sandwich. We're going to have the surface, our thermometer, and more surface. And we're going to put the surface over it because we don't want the sun, the light, to be shining down on the thermometer. We want to be on the surface and then measuring the temperature of the surface. Okay, so let's get this all set up. So here is our model. Look at, we have the light shining on this surface and no light shining on this surface. And I have my phone there to be as a timer for 6 minutes so we can then measure and see the temperatures. If we check both thermometers before we start, we can see that both thermometers are right lit up between that cool and cold. They're exactly the same temperature right now before we begin this investigation with our model. Okay, so here we go. We're going to start it for 6 minutes. Okay, so that's been 6 minutes. So now it's the moment of truth. Now we're going to look and see what the temperatures are. If your teacher sent you one of these, or if you're viewing this in Seesaw and you have this, you can go ahead and fill this out. This is first to make your prediction. You're going to circle around the piece of rubber that you predict to be warmer. And then, like a scientist, you're going to record what your findings were. Okay, so we're going to go ahead and we're going to flip this now up, and let's see, what does the thermometer say? It says that it is hot, right? A little bit very hot, but mostly in that hot area, that 30 to 28. So you'd go over here, look at this one says not shining, this one says shining. So on the shining side, we'd go ahead and we would color in that hot and be like a scientist and record our observations. Now let's go over here to the not shining side, and we're going to go ahead and lift that up. And what is that at? That's at that cool and cold, probably more cold. So I go ahead and color that in, okay? So we just used a model to prove something that we were thinking. So as scientists, we had a prediction that the sun was going to warm the Earth's surface. And so we just used this model to investigate that. And so looking at our data, looking at our results, because scientists, we record our observations, and we can tell that the light, which we were pretending was the sun, was shining on the surface. It was hot. It warmed up the surface. Over here, where we had the surface with no light shining on it, it actually just stayed cold, didn't it? It actually stayed the same temperature it was before we even did the investigation. So this helps to show we only changed one thing. Everything was the same except for the light shining or the light not shining. So we can tell from this that, gosh, it looks like the sun shining on the Earth's surface is going to warm it. So when we think about cause and effect, we know the effect is the Earth's surface getting warmer. We're trying to figure out the cause. And so what this model is showing us that it could in fact be sunlight. Let's try it that way, sunlight. Sunlight is the light that comes from the sun. Let's take a look at some more uses that scientists use models for. Okay, so I have a book that we're going to look at about models today. It says Handbook of Models. Just like when we were learning about plants, we had a Handbook of Plants book. This is all about different models that scientists use. To start out our book, we have our table of contents. Remember, table of contents tells you where you can find all the important ideas of the book. It says some things are hard to investigate is on page 4. So why don't we start there? This is the reason that scientists use models. So some things are hard to investigate. Scientists want to know how the world works. Scientists try to investigate real things to learn more about them. But sometimes they can't investigate the real thing. Why not? Sometimes a thing is too big to observe all at once, like the earth. We can't bring the earth into our classroom to observe it, right? Sometimes it happens too slowly, like a huge tree growing from a tiny seed. This took hundreds of years to grow. So a scientist might need to make a model of that. Sometimes it hasn't happened yet, like a new kind of plane flying for the first time. When scientists can't investigate the real thing, they make models. What is a model? A model is something that scientists make. A model is like the real thing in some ways. It is different from the real thing in other ways. A model is like the real thing in ways that help scientists answer a question. It is different in ways that make it easier to investigate. This right here is the model of a new kind of plane. The scientist wants to know how well the plane will fly. This over here is a model of Earth. Earth is very big. Scientists made the model of Earth much smaller than the real thing. This is a model of clouds and weather. Weather is very complicated. Scientists can use a model to make weather simpler. You can see the clouds and the rain and the water and all of those things in that model. Who uses models? Many different kinds of scientists use models. Scientists who investigate plants and animals use models. Scientists who investigate space use models. Scientists who investigate water and land use models. Many scientists also use models. Models are very useful. Here are two scientists and they're using a model to investigate small animals. Here's another scientist who's using a model to investigate river plants. This scientist over here is using a model to investigate how weather is changing around the world. You see that's moving a little bit closer. Ooh. These scientists use a model to investigate what happens when you put different chemicals together. And this scientist down here is using a model to investigate how to drive on Mars. Models help scientists investigate big things. Some things scientists want to investigate are very big. When something is very big, it is hard to observe the whole thing at once. To investigate big things, scientists often make models. A model can be smaller than the real thing. So here is a picture of a real crater, and then here is an example of a model of the crater that they can keep in their lab and look at. Here we have the real bay and bridge, and here we have a model of it. Okay, so when you think about our model that we did today, we didn't bring the sun in here. We used what for the sunlight? We used that lamp, right? And what was the surface of the earth? That black rubber. So we were trying to create our own model in here to be a scientist. But now just because something worked with our model doesn't necessarily mean that it's for sure going to happen in the real world. So our next lesson, we're going to look at that. Have a good day, scientists.